I'm going to show you an application problem of simultaneous equations. Here's the problem. I want to hire a car to make a week-long trip. A rental company Lausanne proposes car A for 490 francs and car B for 600 francs. In both cases I have unlimited mileage included and I don't care which brand the car is. The problem is that the cheaper car consumes more petrol than the second car. So here's the information about it. Car A costs 490 francs per week and it consumes 10.5 litres per 100 kilometers. Car B costs 600 francs per week but it consumes only 6 litres per 100 kilometers. I also know that the current petrol price is 1 franc 80 centimes. And the question is, which car is cheaper for what distance of trip? So, let's first do a little bit of work concerning that information here. If it's 10.5 litres per 100 kilometers, I need to divide by 100 to get 0.105 to get the consumption for just 1 kilometer. And if I multiply that by 1 franc 80 CHF per litre, I'm getting the price per kilometer. So my calculator tells me that the answer to this is 0.189 CHF per kilometer. And I'll repeat the operation for this. 6 litres per 100 kilometers is 0.06 litres per kilometer multiplied by 1 franc 80, and that is 0.108 francs per kilometer. Next bit, let's set up equations then. Let's call D the distance travelled and C the cost of hire. Let's set up an equation for car A. My total cost will be the 490 weekly rental charge plus that value here multiplied by the distance by how many kilometers I travel. And for car B, a similar equation will be 600 plus 0.108 D. Okay, now I can go about to solve this system of equations. One way I can do this is to solve graphically. I've started setting things up on the coordinate system here. I've already got on the horizontal axis the distance and on the vertical axis the cost in francs. Now what you can see that doesn't work at all is these numbers here. I need to change my scales. So let's have the distance start at 0 and go all the way to 2,500 kilometers. And let's have the cost start at 0 and let's see if 1,000 francs is enough for this. So let's enter the equations. I'll enter equation A. Here I need to use y and x, not c and d for the software. 490 plus 0.189x. That's my first equation. And car B, I will write y equals 600 plus 0.108x. So I can see here that my two lines intersect at this point, which corresponds to the solution to this system of equations here. And if I read down here, it's more or less 1,400 kilometers. Okay, so I can actually ask the software to tell me exactly what the two answers are by choosing this option here. And down here I can see 1,358. Okay, so if I go back to this here, it actually tells me that the distance for which these two costs are equal is 1,358 kilometers. In other words, if I drive more than 1,358 kilometers, then car B will be cheaper. If I drive less than that, then I should choose car A. I can also work out the cost that's associated to that. I look back onto my graph. I need to read across here about 750 francs. It's actually 746.7. So let's go back here. 746.7 francs. Okay, so here I've solved my system graphically. Okay, and I have stopped my demonstration, and I'd like you to do two things. These here. First of all, can you figure out how to do this graphical solution on your graphical display calculator on your TI-83? See if you can figure that out and find the intersection point. So just as a reminder, we did a graph with one line and then the other one, and we looked for the intersection between the two, and we found that the critical distance here was 1,358 kilometers. Okay, that was car A and that was car B. And the second thing I'd like you to try out, which you can definitely do, is solve the system algebraically using your favorite method.